Now we are going to start 17th problem, which is again from 2004 AIPMT. Three particles, each of mass m, are situated at the vertices of an equilateral triangle ABC of side 1 cm. The moment of inertia of the system about a line AX. We know that moment of inertia is not obeying the vector law of addition, so no tension. Calculate moment of inertia of each particle and add all these three results. First, we are going to calculate moment of inertia of A. Its distance from the axis AX is 0. Its distance for A particle which is situated at A, its moment of inertia about this axis should be 0 since R is 0. Going for particle which is situated at B, its moment of inertia m. Perpendicular distance from axis of rotation L square. So it is mL square. Now going for particle C situated at C, we have to calculate this distance. Since ABC is an equilateral triangle, if you drop a perpendicular, it will go to midpoint. It means distance from A to D, it should be L by 2. It is a parallelogram, this angle 90, this angle 90. So this is, it should also L by 2. So particle situated at C, moment of inertia should be m L by 2 whole square. A very easy problem. So total moment of inertia means sum of all three. So no need to take any tension. IA plus IB plus IC, 0 mL square plus mL square by 4. Take mL square common, 1 plus 1 by 4, 5 by 4. So we are getting 5 by 4 mL square. So going with answer C. Next, two bodies have their moment of inertia I and 2I respectively about their axis of rotation. If their kinetic energies of rotation are equal, their angular velocities will be in the ratios. They are talking about only and only rotational motion. In rotational motion, kinetic energy formula, very simple, half m, I is in role of m, v square. Role of v is given to omega in this chapter. So kinetic energy half I omega square. We have two particles with same kinetic energy. For one, I am writing 1 in subscript. For second, I am writing 2. It is given. Cancel half with half. For first, they are saying moment of inertia is I. For second, they are saying moment of inertia is 2I. So what should be the ratio of omega 1 and omega 2? Omega 1 upon omega 2. Cancel I with I. We are getting 2. So what should be omega 1 by omega 2? It should be root 2 is to 1. So very easily we got this answer C. Next, the moment of inertia of a uniform circular disc of radius r and mass m about an axis passing from the edge of the disc and normal to the disc is, what they are saying, you have one disc It is a disk, not ring. Moment of inertia of a uniform circular disk of radius r and mass m about an axis passing from the edge of the disk and normal to the disk means normal to the plane of the disk. So we want to calculate edge of the disk and perpendicular to the disk. We know moment of inertia about this axis. It is which is passing through the center. And perpendicular to the plane of the normal to the disk. What is moment of inertia along this? Half m r square, because it is disk. For ring it is mr square. You want to calculate about an axis which is parallel to this axis and passing through the edge I dash. You can use theorem of parallel axis. I plus m a square. What is a? A is r. Distance between these two parallel axes is equal to the radius of disk. What was I? M r square by 2 plus m r square. So what we are getting? 3 by 2 m r square. So going with C. Next, the moment of inertia of a uniform circular disk of radius r and mass m about an axis touching the disk at its diameter, means end of diameter, and normal to the disk is. Nearly same problem we got in 2005. Again we are getting in 2006. The moment of inertia of a uniform circular disk of radius r and mass m about an axis touching the disk at its diameter. Here they were saying passing from the edge of the disk and normal to the disk. So no need to solve. We have to tick only A option. It was from 2006 AIPMT. The radius of gyration of a circular disk to that of circular ring, each of same mass and radius around their respective axis. What 8 formulas you learned in that theory part? That axis are known as their own axis. If they are not explaining about which axis they are talking, take that standard results which I gave you in starting of this crash course of this unit. In starting I gave you that 8 formulas that all are about their respective axis. So now we have 2 figures. One is circular disk. It is a disk. And second one is a ring of same dimension. It is disk. And it is a ring of same dimension. Mass m and radius r. A ring. Same mass m, radius r. We know that for radius of gyration, we have to equate the moment of inertia with mk square. I am talking about disk, so it should be equal to half mr square. When we are talking about ring, if radius of gyration about this axis is kr, it should be equal to mr square. Divides first equation by second equation. Dividing first equation by second equation. What I am getting? Square of radius of gyration for disk divided by square of radius of gyration for ring is equals to 1 by 2. It means KD divided by KR is equals to 1 by root 2. So we are going with option D. 1 is to root 2. Next, from 2008 AIPMT, a thin rod of length L and mass M is bent at its midpoint into two halves so that the angle between them is 90 degrees. The moment of inertia of the bent rod about an axis passing through the bending point and perpendicular to the plane defined by the two halves of the rod is. It means initially we have one rod of length L and mass M. Length L and mass M. We bend the rod at its midpoint so that we get two halves. And now we are putting the rod in this way. It means this length is L, this length is L. We want to calculate moment of inertia about this axis passing through this point and perpendicular to the plane of the two halves about this axis. It means for both rods, axis is passing through its end point. So we have to use the theorem of parallel axes. See, it is 1/2 part, means its length is L by 2. You know the moment of inertia of rod passing through an axis from center of gravity and perpendicular to the length of rod. What was the formula about this axis? It was ml square by 12. So if I am talking about this axis, I should be m. Now it is a half part, so mass should be m by 2. M. L square. What is L? L is L by 2 by 12. It means for each half, now moment of inertia is ml square by 4 into 2, 8 into 2, 16 by, it was ml square by 12 by 12. So 4 into 2, 8, 8 into 12, it should be 96. I am talking about one part only. By applying the parallel axis theorem, I can calculate moment of inertia about this axis. Suppose it is I dash. What is I dash? It should be ICG means I plus mass. Mass is m by 2. And distance between these two parallel axes, it is now L by 4. A square means L by 4 whole square. So it should be ml square by 96 plus ml square by 4 square 16 into 2 32. You can write 3 ml square by 96. So 4 ml square by 96 means ml square by 24. We have two pieces. For both it is same. So total moment of inertia means sum of both halves means ml square by 24 plus ml square by 24. So what we are getting finally, 2 ml square by 24 means ml square by 12. So we are getting option D. So D option was correct. Next, 4 identical thin rods, each of mass m and length L, form a square frame. Moment of inertia of this frame about an axis through the center of the square and perpendicular to the plane is. Problem is very simple, because moment of inertia is not obeying the law of vector addition. So calculate individually for each figure and simply add all results. So what they are saying? They are saying we have 4 identical rods. We have 4 identical rods and we put the rods in the form of a square. So these were 4 rods. One rod, second rod, third rod, and this was 4th rod. Now, about which axis we want to calculate moment of inertia? Through the center of the square, it means it is passing through this point and perpendicular to the plane. Perpendicular to the plane of the rods. It means about this axis. We want to calculate finally moment of inertia about this axis. So first what we will do, see, one symmetry is there. For all rods, only consider one rod. Calculate moment of inertia about its own axis, what we learned in that theory part about this axis, and apply theorem of parallel axis. Suppose we are finding about this and these two axes are parallel axes. So applying theorem of parallel axis, we are able to calculate about this axis because we have one theorem of parallel axis. The result will be same for all 4 rods because all are at equidistant from this point. All are at equidistant from this point. So it is now not a tough problem. For one rod, if I am calculating about this I, it should be ICG plus mass of rod is m, and this distance it should be L by 2 because center of square is always from a rod at a distance of half of side. So a square means L by 2 whole square. So for one rod I got moment of inertia for first rod. ICG, we have the formula ml square by 12 plus ml square by 4. ml square by 4 means 3 ml square by 12. 3 and 1 4. So what we are getting? 4 ml square by 12 means ml square by 3. So for 4 rods, I should be equal to 4I1. So what we are getting? 4 by 3 ml square. ml square. So we are going with option number D, 4 by 3 ml square. 24th, from 2007 AIPMT. A wheel has angular acceleration of 3 radian per second square and an initial angular speed of 2 radian per second. In a time of 2 seconds, it is rotated through an angle of, first, it is problem related to equation of motion of rotational motion. We have 3 equations. What they gave, first we will write that. A wheel has an angular acceleration of, means alpha is given, 3.0 radian, means no need to convert unit, already SI unit is there, 3.0. Initial angular speed, it means omega naught is there. What is it? 2 radian per second, 2 radian per second. Time is given 2 seconds. All are in same system. We want to calculate theta. We have the formula. S is equals to ut plus half at square. What were their analogues? I write there. We want to calculate theta. We will get in SI unit, means radian. What was omega naught? 2. What was time? 2. What is alpha? 3. What is 2? T2. 2 square means 4. 2 2s are. So 2 3s are 6. 4 plus 6. One easy calculation. 10 radian. So we are going with option A. 10 radian. Next, a solid homogeneous sphere of mass m and radius is moving on a rough horizontal surface, partly rolling and partly sliding. During this kind of motion of this sphere, what we are saying, both rotational and translational motion is associated with this sphere. Total kinetic energy is conserved. The angular momentum of the sphere about the point of contact with the plane is conserved. Only the rotational kinetic energy about the center of mass is conserved. Angular momentum about the center of mass is conserved. So what should we will go? Energy cannot be conserved because plane is not surface. Definitely we have loss of energy due to friction. Only since torque is absent, angular momentum should be conserved. And about rotation is about the axis of point of contact. Rolling is like this. So we are going with B. The angular momentum of the sphere about the point of contact with the plane is conserved. Next, a particle of mass m is equals to 5 is moving with a uniform speed in the xy plane along the line y is equals to x plus 4. The magnitude of angular momentum of the particle about the origin is. This problem is from 1991 AIPMT. At that time, they are giving tough problems comparative to now, which pattern they are going. So see, they are using your coordinate knowledge, knowledge of this chapter, and knowledge of your angular momentum. First we plot that line. To plot a line, you need 2 points. Line is y is equals to x plus 4. It is y-axis and it is x-axis. Now we will draw the line. You can see that the point where line will intersect y-axis, x coordinate should be 0. If x is 0, y should be 4. One point is this. No need to draw this. If y is 0, x is minus 4. Actually, I want to give you feel of the question. If y is equals to 0, x is equals to minus 4. So line is this. Particle is moving on this line. Particle is moving on this line. What is angular momentum? We are saying angular momentum is moment of momentum. It is moment of momentum. So moment of momentum means P cross R. L is equals to P cross R. So now you are going to calculate. So find perpendicular distance of this line from the origin, because particle is moving on this line. You know how to calculate distance of a point from a line? First write the equation of line like this. One side should be 0. If this distance is r, put in place of x and y coordinates from which point you want to calculate distance. 0 minus 0 plus 4 divided by under root coefficient of x square plus coefficient of y square. So what distance we are getting? 4 by root 2. We are getting 4 by root 2 means 2 root 2. And we have to multiply with P. What is P? P is mass into velocity. Mass is 5 units and velocity is 3 root 2 unit. So it means 15 root 2 units. So what is the value of linear moment, angular momentum? R into P. What is R? Because this distance is perpendicular distance, means angular momentum's direction is this and R is in this direction. So theta is 90 degree. So theta is 90 degree means RP sin 90. So it should be RP. What is R? R we calculate 2 root 2. What was R? R was 4 upon root 2. And what is MV? It is 15 root 2 and it is 2 root 2. R is 2 root 2 into 15 root 2. What we are going to get? 15 into 2, 30, root 2 into root 2, 2. So we are getting 60 units. So we got the answer 60 units. Next, it is from 1995 AIPMT. The torque of the force F acting at the point R about the origin is, everyone know the formula for torque. What is torque? R cross F. Remember, you have to write first R. They can confuse you if they are giving the position vectors of point for which F is acting P. R means you have to take direction of R in this way. It is R. And force is acting on P in this direction, means torque is R cross F. Sometimes they are giving you this point A and point P, not giving R. Then if you want to calculate R, take this AP, means position of vector of P minus position vector of A. If you subtract from P from A, you will get a negative marking. So take care of this. R means it should be in this direction, A to P. So now problem was very simple. We want to calculate cross product of two vectors. So what we have to do? We have to solve one determinant. First row I, J, K. Second row from R. Coefficient of I, J, K are 3, 2, 3. Coefficients of F 2, minus 3, 4. How to solve determinant? You know. Hide the row and column of I. What you will get? Top to bottom, top left to right bottom, minus this. So we will get 8 minus 9. It is coefficient of I. I is positive, then write minus j. Plus minus plus, because we are using the concept of cofactors. Now hide j. Again same order, 3 into 4, 12. Minus 2 into 3, 6. Plus minus plus, now write plus k. Hide the row and column of k. Same order, 3 into minus 3, minus 9. Minus 2 into 2, 4. So what we are getting? 8 plus 9, 17 I cap. Cap means unit vector, 17 I cap. 6 into minus, minus 6 j cap. Minus 13 k cap. 17i minus j minus 13 k cap. So we are going with option B. Next, a ball is dropped from a spacecraft revolving around the earth at a height of 120 km. What will happen to the ball? It will fall down to the earth gradually. It will go very far in the space. It will continue to move with the same speed along the original orbit of spacecraft. It will move with the same speed tangential to the spacecraft. So it is very clear what we are doing when we are taking satellites and establishing in orbits. We are doing same. So it will continue to move with the same speed along the original orbit of the spacecraft, because same force, same torque, everything was same. Now it is in air, so nothing is acting on it. So what it was doing in aircraft, it will do same. So it will continue to move with the same speed along the original orbit of the spacecraft. So we are going with C. A couple produces, we have studied in this so many topics, in magnetism, in electricity. A couple produces rotational motion. Couple means two equal forces acting in opposite direction. So we saw in magnetism, we saw in electric dipole, what these two forces will do. They will try to rotate this rod. So we will go with rotational motion. The effect of couple is torque. Find the torque moment of a force F acting at the point R is again given. Same type of problem. Again we got in 1997 AIPMT. R is given, F is given. We want to calculate torque. It means this type is important for you. R cross F is torque. So again you have to solve one determinant. First row with I, J, K. Second row, first you write R. So from R, what are the coefficients of ijk? 7, 3 and 1. What are the coefficient of ijk in F? -3 plus 1 and 5. Now we have to solve first positive. Hide the column and row of I. Solve in this way. 5 into 3, 15. Minus 1 into 1, 1. First positive, second negative. Minus j. Hide the row and column of j. 7 into 5, 35. Order is same. First, top left to right bottom. Then, bottom left to top right. So 35 minus 3, it will become plus 3. Now plus k. Hide the row and column of k. 7 minus 9. So minus, it will become plus 9. So what we are getting? 14 I cap plus 38 j cap. Minus 38 j cap. Plus 16 k cap. 14i minus 38j plus 16k. So we are going with C.